My name is Tom Enebo. I'm a co-lead of the JRuby project. I work for Red Hat. They pay me to work on. Is this better? Yeah. All right. I work for Red Hat, and they're nice enough to pay me to work on JRuby. I like craft beer. I would ask you to come up and tell me something later during the conference, but I'm the last slot, so maybe tell me on Twitter. I've been using Java basically since it started, and I've been using Ruby since 2002. That's also when I started working on JRuby. So this is the roadmap from last September at the last RubyKaigi. I'm just going to go over what's happened since then. We were going to retire JRuby 1.7, and we did. We had a couple of people that asked us to keep it going, but most people were happy enough to move to JRuby 9.1. For 9.1, 2 weeks ago, we put out 9.1.17. I think we've put out 4 point releases since the last RubyKaigi. And last week, we put out JRuby 9.2. Yay. Such a polite audience. It has Ruby 2.5 support. You'll notice in our roadmap that we didn't put out a 2.4 release. I think maybe we can say this was procrastination. We started our 2.4 branch on October of 2016, a couple months before CRuby put out 2.4. By May, we were probably 90% complete. And then by September, or RubyKaigi, we were still about 90% complete. We realized we needed to get moving. Then by December, we were nearly ready. But then we realized that CRuby was putting out 2.5, and we'd only be putting out 2.4. And that just seemed kind of weird to us, so we decided to push on and get out 2.5 support. So that's why we've skipped. There's really only 2 big bullet items for 2.5, or for JRuby 9.2. The first is the 2.5 support itself, and the second is non-ASCII identifiers. When we go and try to add a new language level support, we'll create a new issue in GitHub, and it'll just create lots and lots of checkboxes. Typically, we build this list from MRI's news file. And we noticed something really strange about this. We get lots of new contributors whenever we make one of these lists. I think they go back and they see this nice summary of everything they can work on. They'll look through and go, oh, I'll do string delete prefix. They go into Ruby string, they find a similar method, and they submit it as a PR. I don't really know why this is an issue. If we would have made like 50 issues for each feature, we wouldn't get these contributors, so it's just kind of a mystery. We've also noticed that less people ask us for commit bits. People are pretty happy just to do pull requests, but we're always trying to think about how we can get new contributors. If anyone wants to contribute to JRuby, please do. The other major feature is we now fully support any encodings of identifiers, including for local variables and constants. We sort of supported this in past releases, but there were various weird issues. So here on the left, we define this table flip method that just prints out a message. Then we call that method, and then we use a reflective call methods to get a list of all the methods on the type, which should include the table flip. Well, it printed out calm down, bro, but then when it tried to print out the list, we just crash. And because those bytes we're getting from the table flip method, they're just garbage. So in 9.2, we fix this, and we get the output we expect. Another thing that people ran into, they would try to call a method that contained multi-byte characters, and the method wouldn't exist. Maybe they made a typo. When we actually look at the output, they'll say undefined local variable or method, and then there'll be just some weird numbers. These numbers don't really correspond to the bytes of that multi-byte character. In 9.2, we see what we expect. This third one was the one that we got lots of duplicated issues over. If you try to send and pass a symbol in, we can't find the method. What's really frustrating, I think, for users is, in this case, it prints out the error message perfectly because we're passing a symbol and we know the encoding of the symbol. In 9.2, of course, it works. So you might be wondering why we haven't fixed this in the last 10 years. It's a pretty fair question. The short answer is that for various reasons, we like to go and store and key off all methods and constants using Java's string. We do it for performance reasons. Unfortunately, Java strings can represent different encodings, but they have no way of reporting what the encoding is that it's storing. And also, it was about 5,000 lines of changes to fix this bug. So in the old way, before things worked, we'd go and take an identifier, like the table flip method. We'd parse it into bytes. We'd make a Java string from those bytes, and then we'd go and use that as a key to store our method definition. When we call methods down below, we ask the type for all the keys, but some of those keys we don't actually know what encoding it is, and then we see some of the mistakes that we saw earlier. Now, the solution was, after we get those bytes, we construct a Ruby symbol, and then the string we make is a raw or a binary string. So every byte in the Ruby string is a single character in the Java string. And then we save our symbol to the symbol table using that key, that raw string. And then we also use that raw string to store our method to the method table. Now when we get our list of keys, we have a way of being able to look up something that is properly encoded, and we can print everything out. And it's almost perfect, except for one thing. JRuby or Ruby allows you to have two symbols with the same byte sequence, but different encodings. So this is the one case where we're not quite perfect. This is actually a lot of work to change this. I will say this is incredibly rare. For anything that is, if you have two symbols that can fit into ASCII, in Ruby, we actually just changed its encoding to US ASCII. So this is only in cases of the non-ASCII plane where you can get the same sequences. I couldn't actually come up with an example, so I think that you will not run into this. So now we're going to switch up to performance. The first thing we're going to talk about is Graal. Graal is a new JIT compiler. And when I say new, they've been working on it for several years, but it's starting to come into its own now. It happens to be written in Java itself, and it's bundled in OpenJDK 9 and higher, but it's not on by default. You have to pass an option to enable it. So let's talk about where Graal fits in. So when you first start interpreting bytecode, you might determine that that code is hot and needs to be compiled. And so it gets passed off to the client compiler first, or C1, and it does a bunch of fast optimizations, something that doesn't take very long but has a pretty good performance bump. If that code runs longer, then it gets passed off to the server compiler, or C2. By this point, there's a lot of extra type information, and C2 can spend more time to actually generate much better code. Now, with Graal, by using the JVM compiler interface, we can specify that we don't want to use C2, but we want to use Graal instead. So now we have two different options we can play with in JRuby. So far, our experience has been that sometimes the benchmarks we run are much, much faster in using Graal than C2, but usually it's the same or just a tiny bit slower. It tends to be when the application gets larger and larger, Graal doesn't do quite as good of a job. The reason why we sometimes get really fast results is because partial escape analysis in Graal seems to be much better than in C2. Before we talk about that, we should talk about JRuby's math problem. Whenever we go and try to execute something like 12 plus 2, we have to construct a Ruby fixed num object and then store the long value 12 in it. We have to construct a Ruby fixed num instance and store 2 in it. And these are called boxed values. When we actually have to perform our math, we basically have to rip that field out of the object and perform the math. This ends up having the cost of having to allocate these objects, and it also has the cost of doing these extra like field accesses. But what we want is something that's similar to what MRI does, which is essentially just being able to push a 12 and a 2 onto a stack and execute add. So Graal's escape analysis really helps us here. With escape analysis, it'll try to prove that an object only exists within a particular scope. Once it knows it's in that scope, the compiler can start asking questions like, is there object identity? Is it only like reading a particular field? Once it figures out things like that, then it can say, why am I actually instantiating a Ruby fixed num object? I'll just rip the long field out of the object and just do that directly. And now we're back to having this 12 plus 2 math we want. So let's see what the results are with Graal doing that. I included Ruby just for comparison. I was surprised to see that MJIT didn't really run this any faster. After talking to some people at the conference, it sounds like float math still has some work to go. So it has something to do with all the floating point math in the Mandlebrot benchmark. When we run with JRuby in its default mode, we tend to be a little bit faster than CRuby. When we run with invoke dynamic support enabled, which is actually just using more invoke dynamic than we do by default, we actually have this extra mode because sometimes really large applications warm up slower with extra invoke dynamic support turned on. So as you'll see later, this might not be as true anymore. We'll have to reevaluate that. But now, when we actually get to running it with Graal, you can see it gets dramatically faster. In fact, I was talking about how we have to instantiate a Ruby fixed num for every number we make. We kind of hacked around that by making common Ruby fixed nums pre-allocated into a cache. But this actually hurts Graal's ability to optimize our code. So once we disabled the cache, you can see we got a bit faster yet. And Truffle Ruby right now is holding the crown for this particular math benchmark, but we're about the same speed, and we really haven't had to change anything in JRuby at all other than enable Graal. So the summary for Graal is that it keeps getting better. There's very active development with it. There's rumors that it could replace C2. I don't know. It's been around for 2 decades. I think it's probably a very refined thing that's going to be tough to replace. But it doesn't matter. For JRuby users, you have your choice. You can try both. Oh, and that's the very friendly options to enable it. But try it out and let us know how it works. So another optimization we did for 9.2 is splitting up call frames. Whenever we make a call to a method or a block, we store this extra special information. So if we happen to have just done something with a regular expression, we'll store backref. Or actually, we always store this stuff previous to 9.2. We store block if you happen to have passed a block into this call. And we pass this extra information in because there's these special methods like block given that need to go and look up one call in the call stack and say, was a block provided? So this is how we implement block given. The actual cost of saving these fields is actually quite small, but it's not free, and we see it in one particular case. If we have an incredibly simple method, in this case we're only calling the square bracket or aref method, this is almost doing no work already, so saving all those fields becomes visible now in benchmarks. So you can see in this case, square brackets, we don't know its type, but we do know that there's some square bracket operators that need to look at backref. So we only save backref and not the other fields. If we look at the difference between 9.1 and 9.2, what is that? I'm bad at math. Like it's over 3 times faster. And I added Graal for fun. You can see that Graal almost doubled performance again in this case. So this was a nice little optimization. Here's an example of a slightly less important optimization, but it's a good example of all the small things that we're constantly doing to our code base. Right now, when we do keyword argument dispatch, we actually store the keyword arguments into a real Ruby hash. But we were using an ordinary Ruby hash. So instead, we reduced the hash to have a single hash bucket. So then every keyword argument just became a linked list. And that ended up being a bit faster. And then we also realized we were calling an external set method that was doing extra type checking. Now, while this, I'll show you the results in the next slide. Now, while this actually gave us a small improvement, we're working on a much better optimization for keyword arguments. For most cases, we'll be able to convert those arguments into special positional arguments and get rid of allocating a Ruby hash altogether. So if we call this simple required keyword argument method a million times, you'll see that we got about a 10% bump just by changing a couple lines of code. So we're always looking at this and profiling stuff. All right, JRuby on Rails. We've been running JRuby on Rails, or Rails, since 2006. We have lots of people using us in production today. But somewhere around the 2.3 and 2.4 work, when Rails 5 came out, we fell behind, not so much running Rails core tests, but running ActiveRecord itself. We actually do all of our database access through a library called ActiveRecord-JDBC. So let's talk about how we've changed to go and catch back up. The first thing I want to say is compatibility is hard. If you've never worked on a compatibility project, you might not realize how difficult it is. In the case of ActiveRecord-JDBC, it's crazy. So we have to layer on top of ActiveRecord, and there's multiple versions of ActiveRecord. We use JDBC to go and connect to databases. There's actually multiple versions of JDBC. ActiveRecord-JDBC has to work with multiple versions of JRuby. Right now, at least version 9.1 and 9.2. Of course, we have incompatibilities with Ruby, and we have to cope with differences between Ruby and JRuby. And we run on like 4 different versions of Java right now, and that's just of OpenJDK. We also run on J9 and maybe some other more esoteric JVM implementations. And of course, we have to connect to many databases as well. And there's versions of those, there's special features, there's Java-only features. So It's kind of a worst case as a compatibility project. ActiveRecord-JDBC 1.3 was our last release before Rails 5 support. And you can see we ran with, it would support 4 different versions of JRuby. That's pretty amazing. And of course, it works in multiple versions of Java. I think it supported 4 different versions of ActiveRecord at the same time. It probably didn't work with multiple versions of JDBC, but our code base was littered with old JDBC version checks. And within this one library, we support more databases than JRuby can probably connect to. So the reality is this is just too much to support. In 2008, there were more people working on projects like this. And nowadays, there's just not as many people contributing. And it requires a lot of domain knowledge. When I first started working on the 5.0 support, I'd keep running into lines that looked kind of important, but I couldn't figure out why they were there. And so I was continually asking the question, can I remove this line now? So I didn't actually have enough domain knowledge to know that. But I think this repeated the same mistake that we made in JRuby 1.7. In 1.7, you could actually specify whether you wanted to behave like Ruby 1.8.7 or Ruby 1.9.3. It was in the same code base, and so we ended up trying to share logic. We ended up having lots of if statements, and it ended up being very difficult. But in ActiveRecord-JDBC's case, it's much more gory. So now our new strategy and how how we've sort of fixed this already is we're going to have different branches, and each branch only supports a single version of ActiveRecord. So 5.0 is going to be supported by version 50, 5.1 by version 51, and so on. The other decision we made is that we're only going to support the big 3 databases that Rails supports. We might have to support a Microsoft SQL Server, but there's a pull request to another gem that should add JRuby support. And also, there's Oracle Extended Adapter, so that should be handled by a separate gem. So there should be 5 databases regularly supported now. And the other big decision is when Rails decides that 5.0 is end of life, we're just going to stop supporting branch 50. So far, things are looking really good. When we updated to 50, we went from 1,600 lines of Ruby down to 284. Some of this was removing versioning checks, and a lot of it was just being able to utilize ActiveRecord's core code more, because we didn't have to support multiple versions of ActiveRecord, which is not continuously changing, but changing. The other thing is we got rid of some checks in Java, but most of the Java code we had ended up mostly staying around, but it did get a little smaller. When we did the update for 5.1, we added to add 2 3-line methods, and then it was done. So I think this is working. I don't talk about 5.2 support here. This will be a bit more because they added multiple statements. You can execute multiple statements at once. Although SQLite 3 passes all the tests, so maybe that won't be a lot of work. Anyways, our state of Rails 5.1, which is the latest one that I'd say we fully support with the big 3 adapters, we have 36 failures out of about 800,000 assertions. That's pretty good. And in fact, there seems to be 2 specific bugs that are about 30 of those. This one was most of those. We seem to have just some precision issue we have to figure out, but it's good. So last week we decided to go and look at how our 5.2 testing is going. Action cable won't bootstrap. I think it's an environment issue, but it was last week and I was working on slides. And 5.2, or JRuby 9.2. So we'll look into that when we get back. The The active record test in both of those was SQLite 3. Here you can see that there's 8 failures. Nothing very serious. We can actually run scaffolded apps, so Rail ties somewhat works, but however they're setting up their test environment, somehow fork got in there, and JRuby will never support fork. Never. So the state of 5.2 right now, if you're using SQLite 3, you can make a couple of tweaks to the gem file. Is another thing that negatively changed in 5.2, but you can actually write a full application, and it should just work. And as I said, we have to evaluate the other 2 and figure out the multi-statement support, but it shouldn't be a lot of work, and that'll happen when I go back home. I wanted to show some numbers, and you'll understand later why they're not great numbers. But I decided to show something anyways. We have an internal benchmark suite. We use this benchmark suite to just see if we have performance regressions. So in a sense, you might get a mild idea of performance because I also include some JRuby numbers. So in this first case, I think it creates 5,000 rows of just a string column. So these aren't super realistic queries. And you can see lower is better. This is the amount of time it takes. You can see JRuby actually beats all 3 modes of JRuby I'm presenting. Our default mode, JRuby with extra indie, and then Graal again. You can see Graal is actually beating in Invoke Dynamics, so that's cool. Now, and when you get to the fine benchmarks, we beat MRI just a little bit. Invoke Dynamic actually beats it by a wider margin. Again, these queries aren't super real life, but I'm super excited about them anyways. I said super twice. And the reason is because a few years ago, our queries took about twice as long to execute as JRuby, and somehow we've caught up. And the reason why that we were slower was because of extra transcoding. So when we actually make a database query, if the database is in UTF-8, it gets stuffed into a Java string, and the Java string internally transcodes it to UTF-16. Then when we go back to a Ruby string, it transcodes it back to UTF-8 again. Whereas with MRI, it doesn't have to do anything at all. So the fact that we're actually starting to perform well relative to JRuby is pretty miraculous to me. When we go to select, in the default mode, JRuby with Invoke Dynamic and Graal is doing good. Default mode, it's okay. This is just selecting off an individual ID and getting 1 column back. Again, not super realistic. Find all, this is doing a find all on a like 10,000 row database. We're doing good, doing good. This update one is actually update attributes. I have no idea why we do so well. I can tell you that this works, but I don't know why it works so well. The fact that Invoke Dynamic is 4 times faster is just a total mystery. So here's another set of numbers. We set up an EC2 instance with 7.5 gigs of memory. And it's a simple scaffolded app. Again, not super realistic. I'll explain why in a bit, what I would have liked to have done. But we run the bench, the database, and the application all in the same EC2 instance. Again, making it maybe not quite as realistic. But we're going to do a comparison with JRuby anyways. In the configuration for this was for JRuby, it's running 5 processes with 2 threads each. And in JRuby, we're running 1 process that just is spinning up 10 threads. and we're clamping the memory down to the same size as the 5 JRuby processes, which ended up being, I can't remember if it was 250 or 500. I didn't actually run these numbers. And what we can see is after about 35,000, both modes of JRuby warm up enough where it is doing better than JRuby. So take with this what you will, but it's pretty cool to see us doing well. For the future of ActiveRecord-JDBC, in addition to how we simplified our process, we also want to work more with the core team to push some more of our Ruby code in one sense, so that if they decide they're going to change something, they might be aware of the fact that they're breaking us. The other reason to be more engaged is seeing forks show up in 5.2 tests was disappointing to me. Although I don't blame Rails core, I blame us. We haven't been involved in Rails development in several years directly, and we're seeing the outcome of that, so we really want to get more engaged in Rails core development. So some people might have read my abstract and realized that I was going to talk about Discourse and running Discourse. We were very optimistic. We didn't get Discourse running. We really do want to get Discourse running because Noah Gibbs has been doing a lot of benchmark testing with the Discourse Rails app, and he's doing it with the express intent of showing Ruby 3x3. But why not put JRuby in there so that we can do a nice apple-to-apple comparison? Also, we would just like to go and use Discourse as a nice quality assurance thing before putting out a release. Running specs of like Rails core is fine, but there's so many more errors you find in real applications, it's surprising. So we definitely want to go and get this running. Now on to the problems. So native C extensions is something that we go through an ebb and flow of issues where we'll occasionally run into new C extensions, we'll solve them, and then we'll be good for a couple years, and then we'll look again and there will be 2 or 3 new C extensions that we have to deal with. In this case, I just went through how we're going to solve these problems. CPP-JIBA I've never used, but I guess it's a text analysis algorithm. There happens to be the same algorithm written in Java. So in this case, JRuby gives you the ability to go and script Java types as if they're Ruby code. So we'll go and give CPP-JIBA the right jar file and some Ruby code that'll call into the Java library. And the only thing they'll need to be able to support that is to understand Java docs so they can keep it up to date. And of course, we'll help as needed. For Mini Racer, it's a shim around V8. We have our own gem, the Ruby Rhino. So this is just a platform line in your gem file. Oh, also, same thing down below for PG. We have a JRuby PG. So similarly, just a gem file change. There is no Java equivalent to NocoGumbo that we know of. NocoGumbo is an HTML5 parser, but we don't think that the structs there's not going to be any word size changes. So we think we can just create foreign function interface bindings to lib-NocoGumbo and contribute that back. The definition itself is in Ruby, so it should be reasonably easy to keep up to date and support. And it'll also work in JRuby, so that gives an added benefit that they can test their FFI bindings with JRuby without having to start up JRuby in their dev environment. OJ is a JSON library. I started porting this 2 or 3 years ago, and I almost finished. I was down to one C file, one 6,000 line C file. So I'll have to pick that up and finish it. It's so close. Rinku inspired a Java guy to go and write Autolink Java. So both the authors know each other. We're hoping we can get them to collaborate. I felt like spending a little extra time to talk about how we have to deal with native C extensions. I know sometimes you have to use native C extensions, but I wish you wouldn't. But we do want to work with gem authors. We want to make it as painless as possible to go and support JRuby as well. We try to fit the right solution. Like I said, for foreign function interface, it's a really good fit when we know that the size of the structures and the methods aren't going to change from platform to platform. It might not be quite as fast as a native C extension, but it works well. Java integration, again, as I said, gives you a Ruby syntax. The only downside is having to read Java documentation, but that transition isn't very difficult to understand how we can script Java with the Ruby syntax. We'd love it if there was something in Ruby gems, or at least if the native C extension failed to compile, it would continue to work anyways in a pure Ruby mode. This isn't always possible, but it'd be really nice if it worked. And when we need more speed, we write things with Java native extensions. This is probably the least friendly for the gem authors, but sometimes you need the speed. And this is the equivalent of C extension API, but it's just our API. And the thing we want to do least often is maintain our own gem with a different name. Because if you're an end user, you just want to do gem OJ. You don't want to have 2 lines in your gem file. And if there's only the CRuby line in your gem file, you don't necessarily know that the Ruby Rhino even exists. So we're trying to work with gem authors to reduce pain for you. Every time I practice a talk, it ends up going a little bit faster than I thought. I think I speak too quickly at times. But I'm always 10% faster than I think I'm going to be. So thank you. I think we have about 2.5 minutes. So if anyone wants to ask a question, you can turn on the mic, ask your question, and then after you're done, turn it off. All right. Okay. Going once. Oh, okay, one question. Yay.
The beginning, I have 2 questions. Maybe you already answered it. I had 2 questions. One is there any sort of relationship between JRuby and Truffle Ruby?
Okay, yeah, there is a relationship, but it's more indirect. At one point, both of our code bases were in the JRuby repository, and then at some point they split out because we weren't sharing as much of the same code. Sure. But Ruby Truffle uses a lot of code from both JRuby, mostly our extra libraries like Joni, which is an Oniguruma port, and JCodings, which does all the multilingualization. I think they still use our parser. They also use a lot of Rubinius's original source because there was a lot of Ruby implementations of core methods. But we are also connected in a separate way now in that I presented on Graal, which is the new JIT compiler. That is essentially part of the umbrella of Ruby Truffle. So there's Truffle, which allows you to write languages. And then beneath that, there's Graal, which is the JIT compiler. And we might continue using some more of their technology because there's a project called Substrate VM, which allows you to go and compile to an executable. So there's bits of sharing here and there. Originally, I think we thought we'd be more tied together as a code base, and that didn't completely turn out, but we're still using each other's code here and there.
Okay, so that kind of ties into my second question about kind of maybe roadmap or vision. Kind of, I know Charles tweets sometimes that he wants to knock out issues to move on to like greater things. I'm kind of curious what's the future for JRuby? Anything interesting coming?
Anything interesting
Well,
coming? Well,
notable. Sorry, it's all interesting.
oh, go ahead.
No, I said not interesting, notable, because it's all interesting, but
Oh, I got you.
something.
Yeah, it's all incredibly interesting. Yeah, we've been spending more time the last several months working on compatibility and getting back up to that. We want to keep doing that because we know that 2.6 is soon. I'm speaking a little faster because I think we're out of time. But I'm going to be working on profiling and reworking our inliner. We have the ability to go and do inlining above Java. This is really important for us when we call blocks, because this is one thing that the JVM can't do for us well, is it can't inline a block through a method call back to where that method's called.
Mm-hmm.
So, but we can do it with our JRuby runtime. So we just need to dust that off a little bit and make it start being safe enough to enable. And that should have a huge impact on block-based dispatch. And I mentioned another thing that we were going to do. Keyword arguments ends up being more and more important, and our dispatch isn't what it should be. So we have some plans for making that to be about the same cost as an ordinary call for most normal forms of keyword args.
Okay. All right. Thank you.
Sure. Thank you all for coming. I'm sure I'm out of time now. So thank you.